This one right here?
Yes.
Sure. All right. So here, going through a little bit of vocabulary with that. Transformation representing a flip of a figure. What do you got there, Sam? You think?
Reflection.
That is a reflection. Reflection is a flip. All right. So what do we just say? Reflection. Okay. And then for the next one here, what do we got? Transformation, which is pre-image and image is congruent. What do we got there?
All three.
All three. That is all three. It better be all three. Those again are code for an isometry. Uh, folded so that the two halves match exactly. What do we have there? Another reflection. And then what do we got after that? Moves all the points of the figure same direction, same distance is a
Translation.
okay. And then last one, turn is a rotation. Okay. All right. Other questions from last night? Yeah, Logan. 13, sure.
No, she said skip 13.
What?
You
Oh,
told us to skip 13.
on the calendar. Okay. So I might have said on the calendar there, skip 13. Okay. Yeah, don't worry about that. We didn't talk dilations yet, so yeah, don't worry about 13. That'd be fine.
You do 12.
I can do 12. All right, we'll talk dilations later on. Number 12 then. Find the image of the point C under the compass is a reflection of the x, and then over the y. So yesterday we had talked about, I think following the point over, maybe it was the y-axis, I don't remember. But if you're not sure what, bless you, what it's doing here, I would just make yourself a small sketch of the xy axis, plot that point of 3, -2. So where's 3, -2 at? Starts right down here, and then just kind of, play with it and reflect it over one and then reflect over the other.
-3.
And what should happen is the signs should, change. It should flip. It should be opposites. So first thing it does say over the y-axis, so we're coming over this direction. So C prime.
Let's do the x-axis first, then the y.
Oh, sorry. I don't know where I saw that. All right, so let's try that again. All right, come on. So with that there, you said x-axis. Let's try that again. Going up above here, so we're at 3, -2. We're going to be at what? 3, +2, right? Okay. So we're reflecting it over the x-axis like that. What stayed the same and what changed? The x-coordinate stayed the same, and the y-coordinate became its opposite. Oh, that's new. Why did that turn on? Yeah, I know that. All right, that was a weird one. All right, then we do the y-axis. So then the y-axis, the other one's split, right? So y-axis comes over here, and what is that? Yep. Now I put a C double prime because I've done 2 transformations, but that final answer is what I'm looking for. Yep, -3, 2 right off that. All right, anything else anybody's got from last night? This is your call.
You do number 8.
Number 8. Right, on number 8 here, where we at 8? Okay, so this is where you're going to want to take that patty paper of yours and trace over that graph. That is what we call a cubic graph. We haven't talked anything really about cubics. We'll do a little bit of work with that second semester. All right. On this cubic graph, what again I would do is take your patty paper, trace over that cubic graph, and what are we going to be rotating about? Find the coordinates of the images after rotation. So it doesn't tell me. We're going to just assume it's at the origin then. Okay. So we want to put that on our patty paper. I want 2 things on there. I want that mini XY axis. This time we're at the origin. If it didn't tell me, we're going to go at the origin. And then you've also got this on here as well. So when you rotate it, okay, what we're asking for is where's C and E going to be at then. Okay. So when you rotate that, how many turns is a 180? 2 turns of the patty paper. And which direction are we going? Counterclockwise. So 1 and then 2. Now C prime. Somebody, where'd you get C prime at?
Right. Yeah.
-1,
-1, -1.
-1 it should be. And then E prime should be at what?
-3, 1.
-3, yeah,
M1.
yep, B prime. Okay, 1, 2. All right, and what is that, -3 we want, you said? Yep, okay. So when I see that word rotation, I'm going to that patty paper, okay? All right, anything else anybody's got? This is your time. Go once, go twice. Okay. As usual, make sure your name's on it, throw it in the basket. Again, if you need some patty paper, grab it right up there. Get out your notes and let's turn to the next lesson, please. Page 103, everybody. Page 103. Okay, let's get going here. So what we've been talking about so far over the last couple of days has just been kind of all three of them kind of at once. Today, tomorrow, and then into next week, we're going to then just kind of take the time to talk a little bit more about each one of those transformations separately. So today's lesson is going to be more heavy on focus on just the translation one. Tomorrow will be the reflection, and then next week we'll do some more work with that. Okay? So one more time, page 103, everybody, and let's talk about the translation here. As I said in this book here, sometimes they do things fine, and sometimes it gets a little weird. One thing we're going to talk about here today in just a little bit is the different style of notation or translation. So we'll talk about the translation rule. And again, we're going to use that patty paper because as you flip through the next couple pages, really there's not any graphs for the most part on most of these translations. So that's where that patty paper will come into play. Okay. So as we know here, we can use again that patty paper, or you could just kind of eyeball it. All right. Translating figure and a translation is going left, right, up, down. And it goes that same distance, whatever, same distance and same direction. So wherever this thing goes right here, that's what caught it. Okay, the whole figure goes. That whole square translated horizontally. Which direction you want to go horizontally? Left or right? Right? Sure. So as you translate that, that's where you're going to take that patty paper, copy that square on top of there. Caleb, so let's translate it to the right. Sure. But everything then should go the same direction and the same distance from that. How far you want to go, I don't care. Okay. And then after that, we want to take that triangle and move it vertically. What do you want to do vertically, up or down? Try to make sense to be down. That's where we got the room. How far down you want to go? Then I don't care. All right. But what should happen then is get you again that same picture. All right. The idea is off these translations, it's an isometry. It should be the image and the three-image are congruent. Okay. Now, what we're going to move here in just a minute is taking this one here and not just kind of going arbitrarily however far we want to go, but we are going to go a set distance, and that's where it's going to come into play in just a moment here with our patty paper and some segments as well. So let's just jump right into it then. Let's go to that next page. All right, so here's what we got. Okay, we got ourselves back to these parallel lines and a triangle on those parallel lines. And what we want to do here is on that first question, this is where our book kind of leads us at. We want to draw a translation of each vertex, so each point of that triangle, along the line the point is located on. So we want to take this top point, take along M, and we want to translate each point to the right along a line of distance equal to the segment AB. So patty paper time again. What I would do with your patty paper is, actually don't worry about the triangle here. Get that translation rule. Get that distance of AB on your patty paper, okay? So let's take that distance of AB, let's trace it on there. So we want to basically take this first point, this top point, and just kind of name it nicely. I'll call this X, Y, Z so we can talk about it. We want to take X to the right along line M, the same distance of AB. So let's use that patty paper. So I'm going to take that patty paper, all right, put it on top of X, and wherever that is at, I'm going to find where B is located and just slide my pencil underneath that patty paper. And that gets me the distance of X to become X prime, okay? That's gone that distance with that patty paper right there then, okay? So as you do that, I'm just going to kind of eyeball out myself here because my board freaks out with the patty paper on there. And then do that for Y and do that for Z as well, if you haven't done so yet. And then connect those 3 points, okay? So as we do that for the next one there, Y prime, and then one more, and what do we get? Z prime. Take a step back, look at it, and we could also do this without our patty paper. We could use this as our compass. All right, we could use our compass to open it up to the length of AB, and like we've done before, copying a segment. Essentially, that's what we're doing as well. Our patty paper does that for us too, okay? Now, let's do that same thing, same idea, but now let's take a look at what happens on number 2 then. On number 2, are we gonna get the exact same shape and size there? No, so go ahead and do that again. But as we take a look at that, and we're gonna do that on the next page as well for the last one. Of these 3 things that we do, each one gets something kind of special happening there. And we'll talk about that kind of something special happening there. So take AB again. I think it might be the same length as the first one was. And I'm going to call that, let's see, we did X, Y, Z. That's M, N, and T. So we'll call this what? D, E, F. Okay. So translate that out. Bless you. Okay. And if you haven't done so yet, go ahead and take the other side, the next page. I think there's a third one up at the top there. Take that third one and do that same one as well, please. Slower, Grace. Okay, so go ahead if you haven't done so yet and do that third one, and then we'll come back around and talk about those 3 things. Yeah, thank you, Grace. Thank you. Now, as we look at that third side as you're doing, looks pretty similar, but it's kind of a mesh between those first 2 lines, right? So as we finish this thing off, let's go, let's say D, E, F, so let's go G, H, I. Let's get really creative there. All right, whoops. Okay. So we just did 3 transformations there, okay? Now of these 3 transformations, those 3 get classified as one of, I guess, 3 ways, we'll say it, okay? When we look at those 3 translations that we just did, all right, which transformation produces a true translation of the image?
I mean 1.
Yeah, the first one does, right? It's number 1, it says. So I think it's called question 1. Question 1 does as the, now why did you say A there, Caleb? What's true about the pre-image and the image?
They're kind of growing
Yep.
handshake things out.
Thank you. Yeah, that's what we got here. Okay, thank you. Let me see. So Caleb just said the pre-image and the image are congruent, right? Same shape and same size. So that is a true translation there. All right, so let's throw that now. It'll be in this for me. back to, again, if it is truly an isometry, should be the same shape and size there. Alright. Question 1 does as the pre-image, exactly what he said, and image are congruent. Okay? Now, I've talked about it, bless you. I've talked about it, but we haven't really gone into any type of depth with it. Of the other two that are there, one of them is considered to be a dilation. So before we get to that, when I hear the word dilation, anybody, what comes to maybe mind? Two things come to mind for me. Okay, what's one thing?
Not the same, not congruent.
Not congruent, Lydia.
Pupils.
Pupils is that's one thing that comes to mind, yeah. So if you go to the eye doctor and they put those drops in your eyes and you're like blind for a little bit, or you just have a hard time looking at it, because what happens to your pupils?
Your diamonds.
They get larger, smaller. They get larger. Okay, they get larger. We call that enlargement, and that allows that more light in, and that's why you then go with the sunglasses for an hour or so. You just are like whatever. That's because that's what's happening with those eye drops they put in there. All right, so that's one thing that comes to mind with dilation. What's the other thing that comes with dilation? Anybody else in health class? All right. Well, if you ever, what's that? I say that. I say once you have kids, I guess eventually that happens as well. Those are the two things that come to mind as dilations. So, with that, dilations go one of two ways. Things can get larger, or think of them maybe like a blueprint. All right, where we take the or map, I should say. Take the real world, shrink it on down, then we can also do reductions, we call it. So, as we look here, a dilation then should be the same shape, but the size is no longer the same. Either enlarges or reduces. So what was the one that is it and they considered to be a true dilation up there? Only one of those are.
I think two.
It's only going to be question 2. And the difference is, look at those parallel lines. Or, sorry, shouldn't say parallel. On question 3, we do have one pair of parallels. But what's the difference between question 3 and question 2? We don't have that going on there, do we? If we were to say, go through and take a look at these actual side links, measure them, what we're going to find happening here is that question 2 here, this pre-image to this image, what we say here in math with the dilation, we say, whoops, wrong button. We say that sides are proportional. Now, what do I mean by proportional? Give me a second here. Let's jot that down. Question 2 does, as, whoops, that is not the word as the sides are proportional. So we've talked about proportions, we've solved proportions here. And in architecture, engineering, interior design, that type of stuff, we get into proportions. So what we mean by proportions is that all 3 sides turn out to be the same ratio. Okay, I'm just going to make up a couple links here. Okay, I'm going to say DF has got a length of 2, 1, and we're going to call this 1, and let's make it easier on ourselves. Let's call that 3 and 2. Okay, I'm just saying that those are links. It's not true, but we're going to go with it for easy's sake. When you do a dilation, everything gets multiplied by the same, we call it a scale factor. So on this one here, as we brought that out, what happens then is I'm going to just multiply by 2. So when we say the word proportional, what that means is when you start comparing these sides, they're all in the same ratio. And the same ratio is 6 goes with 3. It's a 2-to-1 ratio. 2 goes with 1. It's still a 2-to-1 ratio. And then 4 goes with 2. This is what we mean by proportional. All the sides should turn out to have the same ratio. If one side does not have that, we say it's not proportional, and it's not a true dilation. It's not a dilation, okay? And that's what's happening on question 3 then. Because on question 3, what we have then is on those lines, we don't have these lines coming out being at the same proportion then. Because this dude kind of screws it up, okay? What we would find out here, and actually, yeah, we actually wouldn't find that out. The only thing we would be able to know here is this dude right here, because this guy is connected from here to here. But after that, we're kind of done for. The other two sides would not be turning out to be in the same ratio as all of them. So we say it's not a dilation, okay? So that's what's happening with the real world as you do maps and blueprints and scale figures. So with here, okay, this is now where, let's talk a little bit more vocabulary, making sure we're all in the same corresponding parts. That's what we want to talk about. So what they've done here for this one here is they've taken this triangle, SQR, okay, and what they've done is some type of translation and they slid it to the right. What they want you to now go through is make sure you can match up the corresponding parts. So what I mean by that is go into that dashed triangle now and go correctly label S prime, Q prime, and R prime. Where should S prime, Q prime, and R prime be? And there are specific areas where those should be at. What we want to do is we work into this topic and we'll move around here. The corresponding parts need to be matching up. Sometimes it doesn't really matter, but as we start getting into kind of the nitty gritty of things, we want to make sure you guys can play the matching game correctly. So this one's pretty straightforward. If you mess this up, we got some issues. S prime, Q prime, and R prime, okay? So they did a horizontal translation. Everything stays in that same orientation. Now, we talked about this, I think into this a little bit yesterday. Look at segment S prime, S to S prime, and look at segment R to R prime. What is true about the relationship between segment S to S prime and segment R to R prime? Sam? Parallel, and there's one other thing? Congruent. Right. That should be happening with that translation there, that everything's going that same distance. So Sam did say they are parallel, and then we follow it up by saying they are congruent. Okay? That should be a no. Now, if we actually go in through and measure all that, that's what letter C does. So we're done with that. Now, what's also going to be true about Q to Q prime? What's going to be true with Q to Q prime? Not necessarily parallel. Well, I guess we could say parallel. I should backtrack that. We can definitely say parallel. Here, I guess we're looking at the distance more specifically, but it is going to be the same thing, congruent. So whatever S did to S prime, that same thing did to R prime, and it also did the same thing from Q to Q prime. So what we're trying to get and keep you guys in or your toes with then is that Q prime is the same length as SS prime and R prime. Okay. So what one does, everything else does in that. Okay. That's what again a translation does. You're along for the ride. Okay. Now I think on the next page, if I remember correctly, that's what we're getting into now, some of the different types of notation styles. So let's take a look at the next page now. I'll give you a second in case somebody's still jotting that down. All right. Maybe not, wasn't. All right, so let's take a look at this now. We finally got our quarter grid here. Okay. What they want us to do then is, we got this translation that occurred. So just like we kind of did with our patty paper a little bit ago, they already did this for you. They took this pre-image and they followed this translation rule right here. They took M, went and created M prime by going that same direction, distance and direction. They repeated that for N to N prime and P to P prime, following that segment AB. That's the translation rule. So how much did it travel? How much did those things travel? What's the length of AB? How do we find the length of AB? I say Pythagorean theorem, or we could use distance formula, but because we have a grid there, just good old Pythagorean theorem. So go find me the distance of AB then. Okay. Go find me the distance of AB. Our Pythagorean theorem will never leave you. It will always haunt you. We got ourselves a right angle, as we know. The horizontal leg with the vertical leg gets me that right angle. And what is those legs that we get? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Somebody get 6 and a 7? Okay, make sure we count correctly. Yes, no? Okay. So it's easy to miscount. And then set it up. Alright, which side is my hypotenuse? That is the AB, which we're trying to find. And again, we've done that all before. Okay? Oops. Okay, so what do we got? 6 squared plus 7 squared equals C squared. What do we got? 36 plus, and what's that add up to? 85? And as we square root that thing, does 85 go anywhere? No, you can do 5 and whatever, but that goes a little farther. So the square root of 85 is the best we can say. Now technically we have again a positive and negative, but this is a distance and it doesn't make sense to say negative square root of 85 units. So what's the distance from A to B? It is square root of 85 units. Okay? Now, I'm not going to do it because it's a waste of our time, but what do you think is going to be true about the distance AB compared to MM prime, NM prime, and PP prime? It's gonna, yeah, it's going to be congruent. It's going to be the same. Okay? They are all the same distances. So if you went through and did that one more time for those three sides, you're going to find it all move the same distance. Okay? All right. So then after that, can you draw another directed line segment on the grid, which defines the translation of triangle MNP to triangle M prime, N prime to P prime? That's a mouthful. Okay, if so, draw the segment on the grid. All right, so here, yeah, we could have taken that translation rule that we wanted to follow. All right, we could have just pasted it up here in that same orientation of having a 6 by 7 right here. That gets me A to B. Yeah, so we could have put that translation rule to some way, and it still is going to map this to this. Hell, we could have slid it down here, and if we get that 6 by 7 happening for the legs, that forces that pre-image to do the same thing. Okay, so yeah, we can. That's a stupid question. All right, so let's flip it. Let's go to the next side here. All right, here's where it's finally at. Is then talking about different styles of notation. So as I keep telling you, when we've done a little bit of review back in middle school at some point, when you start learning about transformations, probably start off within words. Move it right 5 up 3. And then maybe at some point in middle school, you start to solve that other notation we did the other day, where we said that pre-image, apply that translation rule. Did we see that in middle school or not? No? Okay, was the first time you saw that the other day?
Yes.
Okay, no problem there. So ideally you've seen it before, but if not, it's not a huge step, is it? Now, from there, that, like I said, is right around 8th grade-ish. And then from there, we kind of step into the high school, end of high school, college part. And then we get into a couple other ways to write the translation rule. So one other way before we get into the book, I don't know if I remember doing this yesterday with one of the classes, and I can't remember if it was this one or another one. That's another way to write the translation rule, okay? You want to translate whatever point you're talking about. So if we had a point A up here, we would say, hey, translate point A, -4, 5. By using those less than, greater than symbols there, like that is like an ordered pair. In math, that means, hey, do that translation of, well, what's this going to translate? What does this, what's that? Left 4, and then that's all that means, right? So that's when we start to kind of talk about it. And then, I'm sorry?
So these are the rules?
Yeah, it's another type of notation style for that. And then the other type of notation style we run into is then the other one right here in our book. Okay, so let's take a look at this page then, and what would that be? That would be, I guess, like a 4th type of notation. In words, that's easy enough. Top one, that's not too bad. The other one, okay, it's pretty darn similar. Now this last one here, all right, let's read it out. So, as it says there, we can describe the distance and direction of translation using a different type of notation style. Capital T for what? Translation, right? Not transformation, but a translation. Tomorrow, next week, we'll get into R's for reflection rotation. All right? And then right there, this right here is telling you then to say how to move that. Okay? So on this one, all right, on this one here, it's saying take the pre-image, the input P, create P prime by following that translation rule right there. Okay? So give me a second, bring that back. All right. We took, just like we did our patty paper, all right, we put AB on there and we put it on P. Where does P prime then end up? Right there. Okay? So that's what that's going. On the next one here, below that, take P this time and do it whatever AC is. Now AC goes to the, bless you, goes to the left. Bless you again. We put on our patty paper AC. We put A on P, and then where does C land? Right there at P double prime. That's what that's how we read that rule. Okay. So for this here, okay, there it was. All right. What we've got then is identify the translation used to create P double prime. Okay, I really want to phrase that because we just did that up there. They literally wants to recopy that last. So translation of, okay, what they already did for us. Oops. Remember your input. You gotta remember your pre-image. So take that pre-image, that input, and create that, in this case, P double prime. Okay, which they literally wrote right above. That was silly. Okay, so let's go back this page. Let's go back to that banner with that SQR out there. And let's use the notation from the work example to describe the translation of SQR. So let's go back to the banner. Was that on the previous page? Or was that the previous one? One more, right? All right, so one more here. There it was. Okay, so what they did here was, again, we moved triangle SQR to S prime Q prime R prime. Now, do they give us like off to the side, like a key, a translation rule to follow? No. All they did was slide it. So what we're gonna then say then is, what they've slid it was this length right here. So how do we write that up then? All right, let's go back to that page to write that up. We did a translation. Let me write that T a little bit better. We did a translation of triangle SQR to create triangle S prime, Q prime, and R prime. But you gotta give it something to follow. And because they just slid it to the right, we're just gonna say S prime was kind of our key or our guide there. So that's what we got. We did a translation of triangle SQR, whatever S prime was. And by locking that in, Q did that same one, and then R did that same one as well. Okay. All right. How does it represent a translation? All, can't write very well today. All the points moved the same direction and the same distance. Hence why we have ourselves a translation right there. Everything moves the same direction, that same distance, that's giving us that translation off that. Which I think was one of our kind of vocab words a few minutes ago off the homework, as we were talking about things. Okay. So this is our new dude for today. We'll use it. Do you encounter that a lot? After today, I don't know how much. Not today, but after this topic, I don't know. Remember how much it will, but trying to get you used to that different type of notation style. Okay. All right, let's get ready to flip it here. Looking fine on time. Give me a second. Somebody's still jotting down. I guess go ahead and flip to the next page. And let's kind of hopefully finish this thing off. Good, Parker? So let's flip it on that next page then. And all right, so let's do then a translation off this. Okay. Let's use that patty paper again. We're going to do a translation here. Okay, we're just going to kind of do our best to eyeball this a little bit. It's not going to be exact because I'm not going to get into craziness here. We want to go ahead and translate sun, whatever AB does. Okay, so let's take our patty paper here. Let's overlay it onto this. Now on here, I am not going to trace out that sun. Let's just follow point P that they have on there. So on your patty paper, okay, I'm going to trace on P, I'm going to trace on A, and I'm also going to trace on B. Do not then pick up your patty paper or anything like that. All right, keep it in a nice orientation there. And what we want to then do is take our patty paper, and we want on our patty paper, wherever A is, to land on top of them B on our notes. So you got your paper, patty paper, nice and neat. P labeled out, A and B labeled out. And what do we need to do with point A to get it down to B? We need to slide it left and down, right? So just imagine if there is that line there and you're just dragging A onto B, and that distance in that direction that A goes to B, P should follow along, right? So I'm just going to kind of, again, eyeball it out myself because my board freaks out. So P should be roughly somewhere right about there-ish. P prime, okay? Should be roughly about there. What's that?
So we basically rotating it?
You're not rotating it. There's no rotation, okay? We're sliding A, taking your patty paper, taking that A, sliding on top of B. And wherever that does, P follows along, going that same distance, that same direction. Okay. And P prime should be getting right about there-ish. Okay. Now, don't at all like accidentally turn your paper because it does get them be a little bit off. Imagine again a line right along there. We're just kind of, like I said, going through this rough. Let's go translate this next one. Let's read the notation. We're not going to translate the whole moon there, but let's translate P. Okay, P is on the moon. Now, what do we want to follow here for our direction? We want to follow what? L prime needs to go to M. So on my patty paper again, I'm going to put P on there. I'm going to put L prime and M on there. And then I'm going to take my patty paper and I'm going to move L prime onto M. And when I do that translation, we're what? Going to left and down a little bit along that line. P should do the same thing, right? P should go to left and down a little bit as well. So again, on my patty paper, I've got 3 points. P, L prime, and M. Now I'm going to take L prime, slide it to where then L prime is on M. And whatever that does, P should be down here to the left as well. Again, I'm just going to kind of eyeball that a bit. So P prime should be, give or take, right about there. All right, that same general area. Okay. If you have P prime up there, we got some issues. Okay. So whatever that does, we want P prime to do as well. Okay. All right. I think that finally finishes. Yep, that off. Okay, which is great on time. All right, for today, we'll pass it out to you. Alright, so tomorrow we'll come in, we'll go over questions as usual, and we'll then move into the next one, we'll look at deep dive into reflections. Okay? Translations, we've got much more to talk about besides this slide. Okay? We've done our corner grid, now we've done it off of corner giddies and our patty paper as well. Same distance, same direction. Alright. So we got a bit of time here, about 5 minutes. Let's get working on that assignment, please. And I do not want to divide it up. There's no room up here. Stay at your desk. Who cares if the first one out, last one out? Stay at your desk. No, alright? Do not run up there when that's all piece that needed it up and down.